Well, hey everybody. Today, I'm here in my workshop, my happy place. We've got all the cool doodads around here. But the coolest doodad of all is the one I'm talking about today. The Hammond Solovox Model K. So, I certainly hope everyone is familiar with the Hammond B3, A100, M3, all the classic tone wheel organs on everybody's favorite recordings. But I'm here today to talk about one of the lesser known Hammond instruments that I think is really friggin' cool because it is essentially a tube-based monophonic synthesizer from the 40s. And like I said, this is the Model K, so this is the later model, and I'd say by this point, they had really dialed it in. The schematic is very elegant. The circuit is very elegant and incredibly simple. It sounds really good too. So I'm not going to talk about it very much at first. Let's hear a couple samples, and then I'll dive in and walk through the schematic and talk about some of the controls here on the front plate. So I'm going to mute my vocal mic, and we're just going to listen to the synthesizer for a little bit. I might put a little reverb on it from the mixer, but you're going to hear it dry first. Wow, right? I think that's pretty cool. So let's talk about real quick some of the sounds we were hearing and what these tabs are doing, and then I want to look at the schematic, right? So over here on the left, we have tabs labeled bass, tenor, contralto, soprano, mute. We'll go on from there, but this first group, the bass, tenor, contralto, soprano, and the mute, have to do with this mixing circuit right here. And so these are where our octaves are going to come together. So we're going to have, if we click the bass tab in, we're going to have the lowest octave, right? If we click the tenor tab, we're going to have the next octave. They add up together, so you have both octaves now. If I click the bass tab down, you lose the low octave. So it's kind of like your drawbars, right? You can add your overtones. So now we have our third octave, fourth octave. Now the mute basically changes the way the octaves are combined in such a way as to kind of give it a reedy versus a stringy sound, I guess. If I remember right from what I read in the manual, they meant for one to sound a little bit more like a violin, like strings, and I think the other was supposed to sound a little bit more either reedy or fluty. I can't remember, but these are the terminology that they used. So here in the middle, we have some really fun controls. This fast attack right here controls the attack time, so it's on fast right now. So what you hear is as soon as I press the key, you hear it, right? If I click this tab off, we have a slower attack, which is pretty nice. Sounds really good. Right next to that, we have of course the vibrato, which you can turn off. Let me turn the attack back. Flat tone. Same tone with a little vibrato. Now over here on the far right, we have deep, full tone, first voice, second voice, and brilliant. These are our tone shaping tabs. These work in the grid of the preamp tube, and what they do is determine what harmonic content is going to be amplified through the preamp and the power amp. So we have deep tone, which is exactly what it sounds like. Your low frequencies, the highs are rolled off. Full tone, you start to get some more of those highs. And basically, the more to the right you get different resonances in the middle. First voice and second voice is kind of a mid-frequency resonance. And then brilliant is sort of the very top. And same with the octaves. You can turn these on individually or in combination. So here's the brilliant all by itself. Really thin. Brilliant with second voice on its own. First voice on its own. First and second voices together. Full tone by itself. Pretty mellow, pretty nice. And then deep tone we've heard. I love it. All right. So now that we've looked at all of these controls, I want to take a look at that schematic. And so I'm just going to change this view. Apologies. So let's see if we can take a look at the schematic and get it to focus. So like I said, it's a tube-based monophonic synthesizer. And what we're doing here, what makes it monophonic is that we have this master oscillator right here, Right next to it, we have these rough and fine-tuning capacitors, and changing the capacitance in the grid circuit is going to change the tuning, because connected to that grid circuit right here, we have all of the inductors that are located inside this keyboard. So underneath the keys, we've got two contacts. One contact interrupts that big long inductor to shorten the length, and thereby changing the inductance, changing the L of the LC circuit we have in this master oscillator, and giving us our top frequency of that note. So we have one note for each key of the keyboard, and that second contact is the control contact, and what that does is that opens up the output of the amplifier, which is biased off most of the time. So let's take a look. Then we have our inductor inside the keyboard. We have our tuning capacitors. Right here, we have the vibrato oscillator, which is a standard kind of phase shift oscillator. And then has this neat little tube here, which is used to introduce these capacitors into the circuit whenever the vibrato is on. So that's going to change the C of the LC component in that master oscillator. So we have the oscillator, and then a rectifier and driver, and then we have all these frequency dividers, right? So they give you the top octaves, and a couple, more than one octave, which is nice on this keyboard. So they give you those, and then we subdivide the lower frequencies that come out below it for our bass and mid frequencies. All of that gets combined in this mixing network here, and we notice here the mute switch, which is just, like I said, the best way I've heard it described is that we are just changing the way that they're combining these tones. It's only ever going to be octaves, right? Because our master oscillator can only give us one note at a time. So we're just combining these octaves, and that mute switch is just going to change the way they combine. So anyway, once we have our big complex waveform from combining all these octaves here, and there's of course our bass, tenor, contralto, soprano tabs that we looked at over here, right? So we combine all our octaves. We've got a lot of harmonic content coming in to the preamp, and that's where our tone shaping controls come in, right there. So we've got deep tone, full tone, first voice, and you may notice deep tone, we've got a 0.1 meg and a 0.15 in parallel, and the idea is that when that switch is in one position, those are bypassed, so they're not going to affect the grid at all. And then when the switch is opened, those are in the grid circuit, and they will affect what frequencies go through. And so that configuration, the 0.1 meg and the 0.15 capacitor, that's a lot of frequencies are going to go through that capacitor. A lot of the high frequencies are going to go through. Only the lowest frequencies are going to be passed on to the grid. For the full tone, we got a 0.05 now in the paralleling a 1200 ohm resistor. It's going to be harder for those high frequencies to fit through that 0.05, and we're going to get more high frequencies going to the grid and being amplified. Our first and second voice, we've got more capacitors and resistors, but they also introduced these inductors. And what that's going to do is that's going to actually give us a resonance and an emphasis at certain frequencies, which I can't remember now off the top of my head. I think they're around 600 and 800 or so hertz. And finally, for the brilliant, we just add another inductor, and that is going to make it even harder for those high frequencies to go through to ground, and they're going to get pushed on into the grid. Now, oh my goodness. So there are some volume controls here in the output section. This is a fascinating, truly fascinating output section here, and I'm really excited about it. Let me take a sip of this coffee, and then I'm going to dive into it. All right. So check it out. Here in the output section, get it to focus. We're looking at a standard push-pull output section here. Sorry, I'm all over the place. Try not to play the thing too while I'm talking about it. Okay, so let's start right here at T2, right? So coming off of the plate of our preamplifier tube, our 6J5, that is loaded here onto T2, which is a phase inverting interstage transformer. So what that's going to do is that's going to give us our out of phase signals, which are going to the grids of these control tubes, 6 SK7s, both of them, V9 and V10. And the interesting thing about these tubes, there's several tubes that do this, right? It's a subgenre, it's a category of tubes. They are remote cutoff pentodes. So we have our screen grids, and we have our suppressor grids and our control grids and our cathodes and plates. I don't know why I'm listing off all the parts of a pentode, but the idea here is that the grids are wound physically in the tube differently so that they can be fed a wider range of bias voltages, and in those conditions have a wide range of amplification effective, you know. So what you do with this then is they bias it in such a way. So here you can see we have a little resistive network connected to the cathodes of the control tubes there in push-pull. And so we have that. It's connected to the B plus at, what is that, 290? Right? So it's going to have a certain amount of voltage there. This point is normally 150 volts when no key is pressed. So 150 volts on the cathode. And the grids, do we have a good indication? They're going to have some voltage on them too, fed through the center tap of T2. As you can see, that's connected to a resistive network. But that voltage is going to be a lot lower. It's going to be, what is that? Sorry about that. So the idea, though, is that when you press a key, let's follow this line here, right? So we have our resistive network, and then we follow that line right there, that wire. It's going all the way back to our control contacts, right? So the control contacts, when they get pressed, the left side of those 270s, right? Those paralleled 2700, sorry, 2700, that's going to be on ground, right? Boom, boom, that. And so that's going to pull down our voltage over here into a range where those tubes are going to start conducting, where those tubes are going to be brought out of cutoff and into an operating range. And when that happens, the signal that's coming off the preamp tube is actually going to be able to go through the output tubes. And then when a key is not pressed, the ground is removed from the left side of those resistors, and that voltage is able to jump back up, therefore cutting off those tubes. Like I said, the remote cutoff, and I can't remember off the top of my head, the data sheet says you're going to have to push it to, closer to 40, 50, 60 volts to get them to really cut off. Remote cutoff tubes are fascinating. You find them in compressors all the time. In fact, I think I remember seeing these same tubes in some compressors in the past. So that's a neat thing about remote cutoff tubes, and they're used very effectively here. In fact, where you're going to hear it is in the attack time. So here's the fast, and then the slow. That ramps up as that voltage climbs, to where it's going. So, and then of course I just have to address the volume control. There is a knee lever on this thing that I have just sort of, there it is, propped to one side so that it's at full volume the whole time. And over here we have a couple, I don't know if we can see it, a couple of knobs down there that set the minimum and maximum volume settings for that knee lever. So that volume control, soft and loud, as you move that knee lever, it grounds out those resistors, as it goes. And the control, right? So we have this whole resistive network that's set up to control what grid, what voltage is seen by the grid. Let's see if I can just trace that out, because I feel like this is really neat and really important, right? So right here we have our 290, we have some voltage dividers, then we have all this stuff, right? That's just a resistive network to ground. So depending on how you're setting this, you're changing our starting point voltage. We then have another resistor which feeds the center tap. We've got a capacitor here as well, right? So that's going to block any voltage that's coming in from the control, right? It can affect the thing temporarily, which is how that attack switch is working, right? If that changes fast or slow, we're going to have an RC constant there. But over here, the volume control is basically controlling what voltage is seen by both of those grids through the center tap of T2. And then, of course, what voltage is on the cathodes is going to also be controlling the volume. So they're not leaving either one of those fixed, the grids or the cathodes. Normally, with a fixed voltage or a cathode biased situation, either your grids are going to be at a fixed voltage or your cathode's are going to be at a fixed voltage. But Hammond figured out a way where it was, neither. You're changing it all the time if you're moving that knee lever and changing it with the attack control. So yeah, no, it's truly fascinating. And they figured out how to run, the screens and everything else in such a way as to keep it stable. I'm impressed. And it sounds amazing. The swell on that slow attack is just really nice. I haven't quite figured it out yet, but something tells me there's going to be a way to introduce a release control. We have an attack control right there that can ramp up our volume. I'd be really excited to work out a way to give it a little bit of a release as well, because right now the release is instantaneous, right? Even if you have a slow attack, you have an instantaneous release. So that might be something for a future video once I've worked that out. But anyway, let's finish off the circuit. Now that we've talked about the control tubes, finally we have our output section, which I believe we're running 6 6K6s, which is similar to a 6V6, a little bit less power handling. But we have a very sort of standard cathode biased output section. Our coupling caps, we've got some capacitance here across the plates, suppressing feedback, I'd assume. And then, of course, we're connected to our speaker, 6-ohm voice coil. And that is, I believe, just about an 8-inch speaker mounted in there. And, it produces a surprising and pleasing amount of bass, too. So I'm pretty happy with that. Model L. Did I say K earlier? I keep mixing myself up. This is the Model L, which I think might have been the last one they made. Like I said, I've looked at the schematics for a bunch of the other ones, and decided to try to get one of these because I felt like this circuit was the most elegant and the most simple. And yeah, hats off to Lawrence Hammond and the Hammond team, because this is friggin' awesome. You may notice the keyboard looks weird. I figured out in the literature, they meant for you to mount this underneath your piano or your Hammond organ. So you'd have a regular set of keys right here playing your normal stuff, and every once in a while you jump down and play something on one of these things. You can still find these on the internet. I guess they just didn't catch on the way the organs did, which, you can kind of see why if, it wasn't until, if this had come out. Anyway, this thing was just ahead of its time, I think, So, before we call it quits here, I'm going to move this microphone out of the way and show you the tubes. So, yes, we have here, what do we have here? 6 SN and SL7s. In our oscillators, our tremolo oscillator, our master oscillator, we have a whole bunch of 6 SC7s that are doing our voltage dividers. And we have down here our 6J5 preamp tube, our 6 SK7 control tubes, our 6K6 output tubes, and a 5Y3, good old 5Y3. That chassis contains all the circuitry on the backside. We have this big, not that big, I guess, but this big snake wire that comes around to the side and plugs in on the side of the keyboard right there. The power switch is integrated into that knee lever. So if you just they intended this to be installed in churches and just left on, and then when you stand up and walk away from the keyboard, the knee lever swings to the left and turns it off. It's actually a pretty elegant design. There's no fuse in this, and it still has the original 2-prong cord. So right now I've got it plugged into my little box over there, which is basically just it can take voltage anywhere from 100 to 220 and put out 120, and it's got a fuse holder in it. So I'm basically just using it for the fuse holder and the power switch. But yeah, we got our speaker down under there, a little speaker. You can see it just right there. It sounds pretty good like this. It's a little bit unwieldy. Like I said, they meant for it to be installed and just let it run. But I kind of like the idea of it being a little more portable. I kind of want to take this to some gigs and stuff. So I'm considering maybe building this into some kind of suitcase and then building a case to go around this with a handle so I can just set it on, a keyboard stand or on a table, have it sit flat and be able to just play the thing, right? Maybe even have space up top for a few of my modifications. I don't know. Anyway, yeah, I think that just about does it. The Hammond Solovox Model L walk through, talk through, schematic consideration. One last thing, the power supply, right? Got the 5Y3, very standard. RC filters there. We've got our heaters. We've got so we got A couple different heater configurations there for the different tubes. But not a whole lot of filtering. I mean, it's just 3 sections in that cap can, and that's about it. That feeds everything. So engineers figured out something cool there. I don't know. So yeah, thanks a bunch for checking it out, and we're gonna see you next time. Cheers.